Welcome. In this video, we are going to treat this machine learning interview question. It's a question from my ebook. I will put the link in the description. But here the question is, define a Lipschitz. First, define Lipschitz continuity and explain its importance in machine learning. That's a very important concept in machine learning. Lipschitz, convexity, things like that. If we write the maths, let's just write the maths. But basically, that's all it would like. It would look like. But basically it means that maybe I will let you read the maths. But intuitively, what does that mean? That means that the difference between f of x and f of x prime. So I have my input x. And I have another value, x prime. So the difference between those two outputs of my function, they are bounded by the difference between x and x prime. So what does that mean? That means I have x. If I modify x a bit to get x prime, so if x prime that is close to x, then my function f of x cannot change too much, okay? So basically, if I modify x by a bit, my function will change by a bit. It will not jump. You will not have spikes. Okay, because for example, when you do sometimes in training, you modify only your weights by a very small delta, and then you lost spikes. Okay. So here that's usually different. We talk about Lipschitz is a function of the input rather than a function of the weights. Well, we treat the inputs of the neural network as the input when we discuss Lipschitz rather than treating the weights as the input. Maybe that was a bad example. But here really it's I modify x by a bit, then my function f changes by a bit. Okay, and that's very important very important concept. Usually in all generality, neural network are not Lipschitz. But there are ways to make them, to constrain them to be Lipschitz, but it incurs extra costs, for example. You can do it with spectral normalization, and it's implemented in PyTorch. So we've had a few videos covering like adversarial attack. If you've not seen them, I will invite you to have a look at them. But what's an attack? An attack is instead of feeding x to a neural network, you feed x that is very close you feed x prime that is very close to x. From the naked eye, you cannot see the difference. But the neural network, because neural network in all generality are not Lipschitz, you have f of x, it's one class, and then f of x prime, where x prime is very close to x, and it's just a different class. So the neural network, you make a very little modification to the input, on the neural network gives you a very different answer, okay? Only if you make sure that your neural network is Lipschitz, and then this cannot happen. Because if x prime changed by just a bit, f of x prime changed by just a bit, okay? So by having neural network that are Lipschitz, you make sure that your neural network is robust, for example, against adversarial attack, or against noisy perturbation, okay? And that also ensure stable training, because then you have you have bounded gradients, and that avoids problems such as spikes in your training loss, nonce loss, or loss that goes to infinities. Okay. On this stable training is also very important in GANs, and that's why in GANs we usually use spectral normalization in the discriminator. That's all due to that, and in order to have stable training. Here are some references. I hope you might find them useful. I really hope you like this video. That was a short one. If you did, please leave a thumbs up, a comment, even a very simple comment, to give reach this channel to help it grow, and subscribe for more content related to machine learning. Thank you.